Hello, ladies and gentlemen. Let's continue on our discussion of the 2001 Euclid paper put out by the University of Waterloo, those lovely folks who year after year keep giving us wonderful math contests with wonderful questions like 6A here. 4 teams A, B, C, and D competed in a field hockey tournament. Very nice. 3 coaches predicted who would win the gold, silver, and bronze medals. So Coach 1 predicted gold for A, silver for B, and bronze for C. Coach 2 predicted gold for B, silver for C, and bronze for D. Coach 3 predicted gold for C, silver for A, and bronze for D. So 2 people think bronze for D. Interesting. Each coach predicted exactly 1 medal winner correctly. So, for example, Coach 2 might have only been right about gold for B. And you might have only been right for silver for about silver for C, something like that. Complete the table, so I assume it's something like this, in the answer booklet to show which team won the medal. Okay, so they probably would have provided a copy of this table right here, but in the answer booklet. We don't have the answer booklet, so we're going to draw our own table. And we have to sort of do some logic here. So each coach predicted exactly 1 medal winner correctly. So say, for example, Coach 2 was right about silver for C. Well, that means C got silver. So Coach 1 was wrong about who got silver, and so was Coach 3. Not only that, that means Coach 2 was also wrong about who got gold and who got bronze. So as soon as we know C gets silver, that crosses out every other prediction in its row and column. And I think doing this, there's sort of only going to be one way to get... The way it's constructed and the way the question is asked, there's got to be only one way of saying Coach 3 got the gold right, Coach 2 got the bronze right, and Coach 1 got the silver right, that sort of thing. There's going to be only one way to do it, and I think it probably hinges a little bit on the fact that 2 people said bronze for D. Other than that duplication, which to me suggests if bronze for D is correct, then that means that, well, Coach 1 couldn't be right about bronze for C. And so they'd have to be right about silver for A or gold for A, and there's really no way to tell which one it was. Each one seems equally valid. If they got gold for A right, then they'd have to get silver for B wrong, so who won silver? C would have to win silver, but then Coach 2 would be right about something else. Okay. Interesting. It's probably just going to be a lot of me talking here. I'll try and write down some of my more interesting observations in the notepad that I usually write things down on. But, So I guess that sort of proves it can't be bronze for D. And that means it's something else. Something else I might want to focus on is C is predicted for bronze, silver, and gold. So what we could do is we could say, well, suppose C got the bronze. And then what else could we work out? Or suppose C got the silver. Figure out what else we could work out. Suppose C got the gold. And if none of those worked out, then that would mean that C didn't get anything. And that so then each of these anti-diagonals are wrong, and that could narrow some things down for us. But as there's only 2 predictions for the bronze, I'm going to, I think I'm going to start there. So I'm actually just going to, so I don't need to keep flipping back and forth. I only need to keep flipping back and forth in my notebook. I'm going to write down the predictions here. So C was on the anti-diagonal. I think it was A, B, A, and B. And before I move forward, I'm just going to go back and double check. So A, B, C, B, C, D, and C, A, D. Okay. So there are only 2 predictions for bronze. Okay. I want to distinguish these a little better, because so I don't get the B's. The B for bronze and the B for the actual team. I don't want to get those confused at a glance. So we'll put them in green. So there's only 2 predictions for bronze, C or D. Each coach got exactly 1 medal prediction correct. So someone had to have bronze correct. Right? We can't have had 2 people have gold correct because everyone has a different choice for gold. Everyone has a different choice for silver. So one of these must be correct. As otherwise, 2 coaches would have predicted the gold correct or the silver correct. And since each coach had different gold-silver predictions, this can't happen. So the more interesting one is the D as bronze. And I think that's too general. I think that doesn't narrow things down enough. That's going to cause problems. So we know that it has to be either C got bronze or D got bronze. Let's suppose D got bronze. Okay. I'm going to write my table again right here. So A, B, C, B, C, D, and I think the last one was CAD. We have gold, silver, bronze. So let's suppose D got bronze. And before we move forward, let's just double check that I copied the chart down. ABC, CBD, and CAD. Yes, I did. Then Coach 2 was wrong about B getting gold and C getting silver. Three was wrong about C getting gold, A getting silver, and 1 was wrong about C getting bronze. Okay. So right from there, I can conclude that C didn't get silver. So C can't have gotten silver. C can't have gotten gold. C can't have gotten bronze. So C didn't get a medal. So therefore A and B got the gold and silver in some combination. Okay. But A couldn't have gotten silver, and B couldn't get bronze. Or sorry, B can't have gotten gold. This is exactly what I mean. This is why I wanted that green there. So A can't have silver, and B can't have gotten gold. So A got gold and B got silver. But then Coach 1 was right about 2 things. And we were told each coach got exactly 1 prediction right. So this is a contradiction to what we know. We made an assumption, we followed it through logically using every piece of information we were given, and we got an answer that made no sense. Coach 1 had to have been right about 2 different things, or, yeah, that's the only outcome, and that can't have happened because that contradicts an earlier piece of information that we were told is definitely true. So we've done sort of a proof by contradiction. So that means our assumption, and we only made 1, our assumption that D got bronze must have been false. Now we know one of C or D had to get bronze, and we've just shown that if D got bronze, then the whole question sort of collapses, and logically we don't have an answer. So that tells us C must have gotten bronze. So that tells us C got bronze. So hopefully for the last time we'll make our little chart over here. 1, 2, 3, A, B, C, B, C, D, and Coach 3 predicted C, A, D. We have gold, silver, and bronze. Okay. So now we know that C got bronze. So C got bronze. So we can note some other things. If C got bronze, they can't have gotten. They got bronze, so they can't have gotten silver. So Coach 2 was wrong about D getting bronze and C getting silver. Coach 3 was wrong about, well, D couldn't get bronze. That can't happen because we know who got bronze. And we know that C got bronze, so C can't have gotten gold. And finally, what was Coach 1 wrong about? Well, Coach 1 could only be right about one thing, and we know he was right about, or she, was right about C getting bronze. So 1 was wrong about A getting gold and B getting silver. And so that can't be true. Or what am I talking about? That was the only one that was true. So that can't be true, 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 that can't be true. So the only ones that are right are B got gold, A got silver, and C got bronze. So we'll complete the chart in our booklet, B, A, C. Okay, we used some nice reasoning there. It probably would have been faster to do a little yes and check, really, but I like that we were able to logic it out and work it out with pure reasoning. So that was A part. We did just need our final answer, but we have explained our entire process. And now there's only one part of 6 left, and that is B. So in triangle ABC, which we have shown here in this little figure, AB is equal to BC is equal to 25. And AC is equal to 30. The circle with diameter BC, so BC here is the diameter of the circle, intersects AB at X and AC at Y. Determine the length of XY. Okay. So, length of XY. What are we going to do here? Well, I notice I have a line that ends at A, and it intersects 2 points of the circle with X and B. I also have a line ending at A, and it intersects the circle at Y and C. So I'm starting to think of sort of power of the point stuff, which is a nice little result. So I don't know what XY is, but maybe I can at least figure out some values of some numbers here. So let's draw our picture. I think actually I'll just make a little note of PowerPoint over here. That is a terrible circle, and I feel ashamed of myself. So let's try and get this right. And that's alright. So if you have a point out here, and you have a circle, points A, B, C, and D, well, it turns out that AP times PB, these lengths, are equal to CP times PD. This is true for any point, as long as you have a line, you have two lines going through the circle, intersecting at P, you will always have these proportions here, this property here. And it's power of a point. P is the point here. Incidentally, let's move A for a moment. If we know that our line from P only hits 1 point on the circle is tangent, which I'm not drawing properly. If you have a tangent point here, then this is also equal to PT squared, because it'll be PT times PT. And that's a pretty cool result, too. We don't have any tangents in our question right now, but this is a nice result, even without the tangent. So let's draw our picture. Nice big circle. And we'll clean that up a little bit. I should really get some circles that I can just trace on this pad. Whatever, close enough. Alright, so we want to add in our points. We have a diameter here. C, we have B, we have A, we have X and Y. So I don't have an attack plan as such to get what XY is, but I do feel like if I let BX be BX be equal to X, not BX be X, that sounds silly, and CY be Y. So we'll have 25 minus X is AX, and 30 minus Y is AY. So by power of a point, we know that X times 25 minus X must be equal to Y. Oh, no, no, silly me. we'll let that one be x and y. We'll let AY be y and AX be x. That makes a lot more sense. Because I know AB is 25, so 25 times x should be the same as 30 times y. There, I think that'll be better. So AB times AX must be equal to AC times AY, and that will be 25x is 30y. Okay. What have we got here? So I think that actually, because we have a common angle here at, call that theta, but the angle BAC equal theta, doesn't really matter, then since AX over AY is equal to X over Y, which is 30 over 25, which is AC over AB, and angle BAC is theta, which is angle YAX. Then it looks like we have a similar triangle, so angle ABC is similar to triangle. So triangle ABC is similar to triangle AYX. Okay. So XY should be proportional to BC, which is 25. Okay, that looks like it might have helped, but I think we still need one little piece of information somewhere. We're not given anything else in the oh, I think we are. Because, oops, it's questions on the other program, not on the other page. Because AB is equal to BC, right? AB is equal to BC, so that means that XY has got to be the same as YA. So XY, so since AB is equal to BC, then AY is equal to YX, which is equal to Y. So we now know that got a Y here. Okay, so XY is the little value Y. How can we figure out what that value is? I don't know yet. Alright, well, there's one thing that I've been sort of holding off because it doesn't look like it's going to help me right now. But we are told that BC is a diameter, and we haven't used that fact. So this is a diameter. And so one thing I do know is that if you join a point on a semicircle up to the endpoints of the diameter, you get a right angle. I've been holding off on that because I don't quite see how that's going to help me. But who knows, maybe it will. So we'll add in these triangles. And, this here is 25 minus x. And this here is going to be 30 minus y. The problem is I don't know these heights exactly. And so since I don't know those heights, I think I've got it. Okay. Yeah, it's good to play around with these things. Okay, so I don't think I need this one. But I can add in... Okay, so BC is a diameter. So that means that triangle BYC is right angled at Y. But we have a right angled height of sort of AC, or of ABC, and we know that ABC is isosceles. So since it's isosceles, what else do I want to say? So AB is equal to BC, and angle BAC is equal to angle BCA, and BY is equal to... Yeah, let's clean that up a little bit. The point is that ABY and CBY are going to be congruent triangles. BY is equal to BY. That's a silly statement, yes, but angle BAY is equal to angle BAC, which is equal to angle... do I want BAY? Yeah, I do. Is equal to BCA, which is equal to angle BCY. And angle BYA is equal to 90 degrees, which is equal to angle BYC. Then angle ABY is equal to 90 minus angle BAY, which is 90 degrees, minus BCY, which is angle CBY. We conclude that triangle ABY is congruent to triangle CBY. And so from there, AY, which is the length that we want Y, is the same as YC. And we know that 30 is AC, which is 2Y. So 30 is equal to 2Y. Y is equal to 15. And I think Y is exactly the value we're looking for. Yeah, XY is equal to Y. So xy is equal to 15, and that is what we were asked for, right? Determine the length of xy. Well, there we go. We have it. It's 15. All right. Nice little question. And that does it for B part. So we only have a few more questions to go. And in the next video, we're going to take a look at question number 7. Also has 2 parts. But, these questions are taking a little longer because they're getting a little harder, as they should. I don't even want to imagine how long question 10 is going to take me. We'll find out in a couple videos. But first up, question number 7, and we'll take a look at that next time. Thanks for watching as always, and I'll see you in the next video.